Okay. Hello, everyone. Hope you all are doing well and safe. First of all, I would like to thank Keshan Soidimana for joining with GDG Adelaide for this session. He's a Google developer expert in machine learning and has extensive knowledge about NLP. So let's get started. If you have any question, wait until the end of the session. So we will be able to help you. So let's get started. Keshan?
Yeah, hello. Can you hear me? Okay, I think you can hear me. So, hello to all the beautiful people from Adelaide. I hope everybody is safe, healthy, and happy despite all the bad things happening around. So today we are going to just briefly talk about NLP, that is natural language processing, and we will try to understand some of the components, some of the things that we could do to understand as a beginner to understand uh, the fundamental stuff with natural language processing and to know something to get started in this domain. So before I start, let's talk a bit about. Let's refresh your mind about the traditional paradigm, or the way that you have already known to program. So usually, what you do is, given a problem, uh, you will come up with rules or some conditions to write a computer program in whatever language. It can be Python, Java, JavaScript, whatever the programming language. That this is how you have been developing programs. You write the rules. Let's say, for example, if you want to write a program to calculate taxes, okay? So you know the rules, and what you do is you write a bunch of instructions, and basically you use if conditions, else condition. I mean, these kind of different conditional things that you have in your programming languages, and then once you given the data, you can produce an output. That's how you have been programming, and that's how everybody is programming, and that's a very good and a proven methodology. But the problem is, it's good for most of the problems, but when it comes to very scalable problems and sometimes things that we taken for granted, for example, the vision or the language or the speech, which is not easy to write rules to understand, or teach a program how to teach a computer how to understand, let's say, vision or a speech or a human language. So that's where machine learning comes in to scale this already proven paradigm. And in machine learning, what it does is, it simply, without rewriting the rules, it simply try to find a mapping between the data and outputs. So how we train a machine learning model. So this algorithm, I mean, whatever the thing that in the middle, we call it as a model. So how we train that model is, you give bunch of data and a bunch of outputs or the results, and we ask the machine to learn a relationship between these data points and the results. For example, if you want to write a program to classify dogs from cats, what you do is you will collect a bunch of images, a bunch of maybe hundreds of thousands of, maybe even millions of images of cats, and also of dogs. And then you have a label means, let's say, you put all the cat images into one folder, and then you put dog images into one folder. So in that way, we have a proper labeling, and then we tell the computer, okay, this folder contains cat images and this folder contains dog images. You can try to understand a relationship and differences between these two classes. So once it has learned, once we train that model, then it will, I mean, this rules part is the model, like it has known a relation, I mean, it has learned a relationship. Then we give another new data point. Using that rules, it can give you an output or a prediction. So in a nutshell, that's how machine learning works. But today, we are not going to classify dogs from cats, but uh, it's languages, human languages, which is not really easy as, images, because we have to work with strings, words, sentences, and the languages, like not only English. There are like more than 6,000 languages in the world, and each language has its own unique styles, patterns, maybe grammar, vocabulary. So there are so many things that we need to know in order to, before working with natural language processing. And if you think about an image, you can simply convert it to numbers. For example, we talk. I mean, although we see colors and shapes and layouts in an image, for a computer, it's just numbers, right? A pixel means, when we talk about images, we talk in, let's say, 400 by 400, like 1,000 by 1,000, that kind of number, like, which is 1,000 pixels and 1,000 pixels. So that is the dimension of the image. So which means you have 1,000 images to the x-axis, and another 1,000 pixels for the y-axis. So in that case, you have like 1,000 by 1,000 means million pixels in that images. So one pixel is a number between 0 and 255, so 255. So it's easy for a computer to understand. Understand means convert images into numbers, because machine learning algorithms, whatever, whether it's a neural network or any other algorithm that you use, uh, doesn't know how to work with any other like data structure. I mean, any other data types rather than numbers. It just know how to multiply numbers, add numbers. That's all it knows. So so we have to come up with a way to convert these languages into proper, to integers or numbers, that integers or floats or whatever the numbers that a computer can understand. So that's the first kind of the step in natural language processing. So let's take this as an example. Today is a beautiful day. So this is a usual sentence that you might come across in a day-to-day life. And if you pay close attention to this, uh, you have tokens. Like, in a sentence, you have different tokens. So token can be a word. It can be, maybe may not be a word. Like, it can be the question mark, it can be exclamation mark, or it can be the full stop or the period if you're from America. So so the next step is to tokenize. So we call it tokenization. And for simple reasons, we can simply tokenize, or I mean tokenize this sentence by splitting the sentence by the space. So which means today is one. Today means, today, the word today is a one token, and is another token. So likewise, we have one, two, three, four, five tokens here. uh, but the thing is, there are languages which doesn't have space as a separator, word separator. Like, if you take some languages, especially in Southeast Asia or maybe Far East Asia, like, they don't use space in between words. Like, for example, that I know that the language Thai, which is the language of Thailand, they don't have this space as a word separator. So in those kind of languages, we need to do a few more processing to get it to this kind of a situation. But if you take English, for example, now, because I guess everybody understand English. So so here, like, in the simplest case, we can use space separator as a tokenization. But when you do real world NLP, that is not commonly used. There are other tokenization methods that you use to uh, do tokenization. But the takeaway is, tokenization is one of the initial stages that you do in natural language processing, where you simply chunk your sentence into smaller parts. So that's simply the tokenization. So let's tokenize it by word, let's say, as a simple example. So and then you can give a number. Like, you can simply create this as a vocabulary, and you can map it to a number, an integer. So here, today means number one, is two. So likewise, you can create a vocabulary out of this sentence. Let's say you have let's say you have collected lots of examples. Let's say you have a couple of millions sentences in your vocabulary, and you can simply get all the unique words, all the unique English words, and then you can map those words into numbers, right? And likewise, you can create a vocabulary, and then when you get a new sentence, you can find which are the numbers related to those words, and create a list of numbers as a sentence, right? So conversion part, uh, and that way you can create a you can convert these sentences into numbers. But if I show you this example, uh, here the bank. So usually, like if you create that kind of a vocabulary, so bank might have just one number, but bank can have, I mean, this the word bank can have like few meanings. So in this case, we know, unless the situation is not like this, the bank in that particular sentence refer to a bank like the river bank, not the financial institute. So how did we make that conclusion? So if you ask a human who speaks English, that person can definitely understand this bank is not the financial institute, but the bank in a river, on a river. So if we ask how did you, or why did you say that, they can simply say, because of these two words, I have I have a higher confidence that this bank mean refer to a bank on the river, but not the financial institute. So which means when we work with languages in natural language processing, we need to think about the context as well, the context where we use the we use the word. So for that, uh, we have come up with, I mean, not we means the researchers have come up with lots of methods. So one thing is this word embedding. In word embeddings, what it does is it tries to it basically gives lots of sentences to a particular, let's say, particular algorithm, let's call it, because everything that we don't understand, we refer to it as algorithm, right? So in that, so what it does is, in that algorithm, it will try to like statistically understand what are the most related words, like, and it kind of learn some features. Let's say, for example, it kind of understand the gender between words. Like, for example, it here, like, if you take king and queen, some royalty. So basically, you can think it as a royalty feature. So that royalty, like this royalness, could be one feature, and the gender could be another feature. So that's why, if you have read about NLP, you might have come across an example where they do arithmetic on words. So here, for example, if you minus, or if you subtract the gender from king and add the women part, you will get queen. Like, king minus man plus woman means queen. So that kind of arithmetic that you can do on word embeddings, that is because you have converted these words into vectors. So vectors means nothing but a list of integers here. So integers or floats, I mean numbers. Let's call it numbers. So list of numbers. So the king here means, let's say, it's an array of numbers. Uh, so you can do arithmetic on these uh, like number arrays, right? So the numbers inside this array means a feature, which means it could be the royalness or the gender or something else that it might have learned. So not just simple nouns, but it learns the verb tenses, and also the country capitals. Like, for example, it has an idea means we don't know the conceptually the idea that the machine learning model has learned is similar to what we as humans have. But some statistical understanding is there, but it doesn't mean that it might know the conceptual idea of a country or a capital. So let's say if you subtract Madrid from Spain, and if you add Canberra, then you might get Australia as the result. So that's how word embeddings works in a nutshell. Now, how can we use it? So that's the basic concept. That is pretty basic conceptual idea. But the real thing is that you have to use this in a program in coding. Like so one of the easiest ways to use a library like TensorFlow, where the these algorithms or these methods have already been implemented. And this text vectorization is where we use a sentence and then convert it to numbers. So in order to do that, we have to first import the vectorization layer from the TensorFlow, from the Keras, TensorFlow library, and then you can use it like this. You can initiate you can define it with different variables. For example, how many tokens that you have. What is the maximum tokens that uh, you want to use? And here we are converting it to integers. That's why the output mode is int. uh, and then when you do the adapt, when you call the adapt method on this text data set, so this text underscore ds means a data set where you have multiple sentences. And when you call adapt, it will simply convert these words into numbers, and it will also create a vocabulary to find the mapping. And let's see how to do a sentiment analysis. There are so many applications in NLP. So one thing is understanding sentiment of a sentence, or maybe you can use it to classify documents, or maybe you can even come up with new ways to write poetry. Like nowadays we have models where you can use to generate text, which means you can write poetry, stories, uh, and also there are so many other applications with NLP. Even Google search heavily use NLP to give you better results. Uh, so let's see how to do a very simple sentiment analysis using the concepts that we already discussed. So initially we need a input layer where you will get this text vectorized numbers, like the numbers, not the words itself, but the converters. Initial steps that we converted words or the sentences into list of, or the arrays of numbers, and this layer is to hold that values. And then in the next step, we use this embedding layer. So embedding layer is where not just a number, but we will simply create an, an array for a given word. So in this layer, it tries to understand the context and different meanings, or different concepts between given words. And then you can create whatever the model that you want to create. uh, it could be a very simple feed forward neural network, or maybe you can have maybe some convolution layers there. So it depends on the problem that you are going to solve. And uh, and then in the output layer, why we are using a dense layer with just one neuron. That's because we are doing sentiment analysis here. So sentiment analysis means you have just have a binary prediction, like negative or positive. That's why we just have one neuron here, one output here. And then it's the usual stuff. You create the model, you compile the model, and then you train the model with the given data set. Okay, so that's basically it. Now I know what everybody is thinking. I think I have read your mind, right? So let's see how a working example looks like. Okay, I'm reconnecting, and then I will maybe just. Okay, I think everybody can see it now. And you have the first mesh. So I'm using Google Colab here. If you don't know Colab, just go to Google and search for Google Colab, uh, and you can see the Google Collaborative tool. So this is a very good and easy tool to use. So this is basically a Jupyter notebook hosted, and we can use uh, for free. and especially you have GPUs here. So make sure for this example to use the GPU. So we get all these things for free. So I highly recommend you to go and try out. So in this example, addition to what we have already discussed, I'm giving you a few more tools and methods to your arsenal, like TensorFlow datasets, TensorFlow Hub. I will tell you what are the importance of these libraries. So, uh, so TensorFlow is a library where all the meat, right? The algorithms, all the mathematical stuff is going inside this TensorFlow library. And this TensorFlow dataset is where you can find a lot of publicly like openly available data datasets where you can even use for commercial purposes and mostly for educational purposes to understand or maybe build better models. Uh, and TensorFlow Hub is a good place where people have already built some models and publish them openly for anybody to use. So you can use these models maybe in your as an application, or maybe you can use these models and uh, and do some transfer learning, which is a very common thing that people do in nowadays in the recent time, especially in computer vision domain, and also now in natural language processing domain. Because uh, let's say if you are building a new uh, let's say a sentiment analysis model, rather than just using your data set, if you can already use a pre-trained model which has been trained on millions or maybe billions of sentences, and then use it and do some fine tuning with your limited number of data that you have, and get a better performance. uh, that's the goal of using pre-trained models. So let's run it and see whether we have the GPU available now. Uh, yeah, we have a GPU. So why we use GPU is because uh, these processors are very computational heavy, and it does a lot of matrix multiplication, and it's easy and faster to do those operations in a GPU rather than on the CPU itself. You can definitely run this stuff on CPU, but GPU is much, I mean, way faster than using just the CPU. Okay, so let's say if you don't have a CPU, sorry, GPU in your machine, and if you don't want to use Google Colab, uh, you can still run it, but the performance might be very low. So now let's load the data set. This is IMDb review. So I think everybody know what IMDb is. It contains a lot of movie reviews, and this data set is publicly available data set where it has uh, the review and also a kind of a sentiment where humans have labeled them, saying that this is a positive sentiment or a negative sentiment. So we are going to load it into three separate buckets. Buckets means like you have training data bunch, and then you have a validation data, so and a test data. So why we use these three? Because you don't always use the training data to evaluate your model. So we train the model with this training data, and then while we are training, we validate the model with this validation data. And once we have developed our model, and if like once we build our model and we are confident with our model, we finally use this test data to get the final evaluation of our model, right? So we are going to load this data set, and let's see some of the examples. So you can see some of the examples from the data set. If you look at the label, so in the first case, it's zero, means it's a negative sentiment. So this was an absolutely terrible movie, of course, which means a negative sentiment. Likewise, you can load and see, like, just do some sanity checks whether your data set contains some issues, things like that. So let's assume that we have already like the data set is already clean and have no issues. Then I'm going to use this TensorFlow hub. So in the example, if you remember, in the previous example, we were using an embedding layer. We did the text vectorization ourselves, and we used an embedding layer inside the model, and we did it inside our models. But instead of that, what we are going to do is we are going to load an embedding layer from a pre-trained model. So let's look at the model. If you go to this model, so this TensorFlow Hub contains tons of similar models, not just for text, but also for vision and all the other possible scenarios that you can think of. You can simply use them. So why this is good? Because this model is already trained on 7 billion word corpus, so which means it's huge, and we can safely assume that it contains almost all the words that we come across in day-to-day conversations in English. So if we use this kind of a model, which means we could get a better results than we do that by ourselves. uh, Now let's so this is how how simple it is to load that model into your load that model as a layer into your model. Just use the hub.keras layer. So hub means the one that we imported here, and it has this keras layer, and you simply give uh, the the link to your model, the link to the model. And if you want to look at more examples, you can see some of the examples in the model page itself. Now let's load it, and we see a simple example here. May it may not be really helpful, but you can do some sanity checks by looking at the data and shapes of the examples, likewise. And then we built a very simple model. So this is a very simple model. You just get the embedding layer from that hub, and then we simply add a dense layer with just 16 nodes. And then on the output layer, we just have another dense layer with just one, because we are just going to predict negative or positive, right? So here's the model summary. We have the initial layer from the TensorFlow hub, and then we just have two other layers. And then we do the compilation, and then we fit the training data on the data set that we already have here. So we are going to train the model with the training data. We are shuffling and creating batches. That's a very good practice to do. And we are simply running it for 10 epochs. And we are validating the model on the validation data that we created initially. Uh, and if you look at the validation accuracy, uh, you can see it's going up. So the validation accuracy is going up, means that's a good sign. And yeah, since it's running on GPU, it's quick. I mean, it's faster than running on CPU. So we have already trained 10 epochs, and our accuracy is going up. Not in, like in the last step, maybe it has gone down a bit, but anyway. So let's get the results. So we are evaluating now evaluating our model on the test data. So if you see here, like we trained it on the train data, and while training, we validated the model with the validation data set. And then once we are done with it, we have evaluated our model on the test data, just to get a better idea or be more fair. And we have a model with almost, I mean, not almost, like more than 85% of accuracy. So it can predict now, like we have already built a model in just a couple of minutes uh, to uh, to predict the sentiment of a sentence with the IMDb movie review data set. So I think that's all I have. Uh, yeah, thank you very much for joining in, especially in this kind of time. And if you have any questions, please feel free to ask.
Um, Thank you very much, Keshan, for the session. So let's see our chat if we have any questions. Mm, from the look of it, currently we do not have any questions from the audience. So anyway, I would like to thank Keshan for joining with GDG Adelaide for this session. Thank you very much, Keshan. So we will see you again for our next session from GDG Adelaide. So take care, everyone. Thank you.
You too. Bye.